everyone. Welcome to your FRQ practice on free energy in ecosystems. In this video, we are going to be looking specifically at an FRQ style question that deals with how energy flows through the ecosystem. So you're given the prompt, an energy pyramid for a marine ecosystem is shown below. Label each trophic level of the pyramid and provide an example of a marine organism found at each level of this pyramid. Explain why the energy available at the top of the pyramid is a small percentage of the energy present at the bottom of the pyramid. So this FRQ is looking at how energy or free energy flows in an ecosystem. And what you all have learned from your free energy notes is that without this free energy, organisms and ecosystems would die. And if there is an abundance of free energy, this would lead to either storage of that energy or growth in the organism or in the size of your population. Now, all free energy ultimately, for most of the organisms on Earth is going to come from the sun in the process of photosynthesis. So organisms that can capture sunlight and use it to make chemical bonds are going to be the basis of our pyramid. These are known as producers or autotrophs. So organisms such as plants and cyanobacteria are able to capture the sunlight and use it to make glucose. So in a marine ecosystem, we can put here phytoplankton, we could put here seaweed, we could put here sea grass, any type of producer that is in a marine ecosystem, so in an ocean or aquatic system, anything that captures sunlight and uses it to make glucose. The next level up are known as the primary consumers. These are going to be organisms that eat the producers. You can also call them herbivores, but they're any organism that directly eat the producers. So in this case, I'm going to put something small, like shrimp. The next level up are known as your secondary consumers. These are going to be organisms that directly eat the primary consumers. So let's say fish. The top level of this pyramid is known as the tertiary consumers. These are going to be organisms that directly eat the secondary consumers. So let's say shark. So we have an energy pyramid, and what you'll notice is that it is progressively getting smaller as you go up each level. So producers is the widest, it's the largest base, and then as you go up each level, it gets smaller and smaller and smaller. And the reason why has to do with thermodynamics, something we had talked about back when we did free energy. We had discussed the two laws of thermodynamics, and we had also indicated something very important for the second law of thermodynamics. In chemistry, you learned the second law of thermodynamics as entropy. And the example or the way that this manifests in biology is that every time there is an energy exchange, there's going to be some energy lost as heat. In other words, as the consumers eat the producers, the amount of energy that the consumers are going to get from the producers is not 100%. And there's something that we call the 10% rule. Basically, what it boils down to is that roughly 10% of the energy that is in the producers, in the biomass of these producers, only 10% of it would be available at the next level. The rest of it is going to be lost as heat. So for example, let's say that in our producers, we had 4,000 kilojoules of energy available from all the photosynthesis. When consumers eat producers, not all of the energy that is available is going to be directly converted or given to the consumers. In fact, most of it, 90% of it, will be lost to the environment. So only about 10% of the energy that's available in producers is going to be available to consumers, which is 400 kilojoules. Then from there to the secondary level, only 10% of the 400 is going to be available to the fish. And from there, only 10% would be available to the shark. So what you see is that every time you move to the next level above, only 10% of the energy is available to the next level. And so it gets progressively smaller and smaller and smaller. This is because every time there's an energy transfer, some of that energy is not going to be transferred to the next level. In biological systems, most of that energy will be lost as heat. So in your written responses, we would be looking for something like this, or something that included the following bullets. So we would be looking for the idea that the producers are capturing that free energy from sunlight. Now they need to use some of that energy to grow, or if there's excess free energy, they can also use it for storage. Only 10% of the energy captured would be available to the next level, so you would see it getting progressively smaller and smaller. The rest of the energy that had been captured or from the producers or whichever level it is, the rest of it would be lost continuously as heat. And this is known as entropy in chemistry. I hope this video was helpful to y'all. Thanks so much for watching. Bye.